Hello everyone, today I'm presenting my research midterm presentation for IPI 496. We celebrate satellites for GPS, weather forecasting, and global communications, but what about the infrastructure on the ground? Launch sites, fuel storage, testing facilities, these all leave environmental and social footprints that rarely make headlines. My driving question: what are the hidden environmental and social costs that ground infrastructure imposes on local communities and ecosystems? And how should we weigh these costs against the benefits? Cycle 1: Global Biodiversity Threats. Cycle 1 established the global scale. A 2024 study in Communications, Earth and Environment analyzed 226 launch sites worldwide, and launches have increased 175% in the past decade. 67% of sites are coastal. Why? To exploit Earth's rotation and keep debris over water. But this concentrates infrastructure in sensitive ecosystems. Mangroves host the highest launch site density, over 5 times greater than any other biome. Here's the tension: 90% of sites where unprotected habitat exceeds 50%, yet 62% operate within or near protected areas. Impacts extend 45 kilometers for chemical contamination and up to 1,500 kilometers for debris, with documented fish kills, heavy metals in sharks, and Arctic contamination. The success of this cycle was quantifying global exposure. The gap: excellent biodiversity data, but limited insight into social costs, community displacement, fishery economics, and that led me to Cycle 2. Cycle 2: Bioaccumulation and Synergistic Toxicity. Cycle 2 examined the toxicological pathways. A 2021 chemosphere study asked, are we neglecting Earth while conquering space? The study organism was a freshwater shrimp used in local food systems, directly linking contamination to human diet. Key finding: shrimp accumulated aluminum at 2-fold higher levels than controls through particle ingestion, even though the particles are barely water-soluble. This challenges the assumption that launch site debris is rendered inert. Under acidified conditions, simulating rocket exhaust, the effects were synergistic: neurotoxicity, metabolic depression, and respiratory impairment from clogged gills. The critical insight: alive does not mean healthy. Standard monitoring counts dead fish. It misses organisms that can no longer grow, reproduce, or escape predators. The success of this cycle was identifying the particle ingestion pathway that evades standard water quality monitoring. The gap: we have proof of toxicity in the catch, but no data yet on human health outcomes. And that led to Cycle 3. Cycle 3: Trophic magnification in apex predators. Cycle 3 delivered the smoking gun: field data from Brazil's Alcântara Launch Center. The study organism was the Atlantic nurse shark, a bottom-dwelling species with high site fidelity, meaning its body reflects local contamination, not diffused global pollution. Results: mercury at 106 times regional levels, the highest ever recorded for any shark species, and rubidium at 7 times Arctic levels, rubidium being a chemical fingerprint for space fuel. This traces to the 2003 VLS-1 explosion that killed 21 workers. The sharks, being benthic, continuously feed on contaminated sediments years after the disaster. Despite extreme metal loads, they showed no activation of detoxification pathways. Silent accumulation without physiological defense. Here's the social-biological intersection. Alcântara operated for 40 years without an environmental license, and the region is a global hotspot for shark meat consumption. Yet, the 1972 Liability Convention excludes environmental damage entirely. The biological chain is now complete. Toxins leak, invertebrates ingest, apex predators magnify. The remaining question is legal, and that led to Cycle 4. Cycle 4: Legal liability gaps. Cycle 4 asked, why is this allowed to continue? The answer lies in the 1972 Liability Convention. The convention defines damage as only loss of life, personal injury, or property damage. Environmental degradation, the silent bioaccumulation that I've documented, is explicitly excluded. Claims must go through diplomatic channels by a state. Local communities have no direct standing. Legally, they're collateral. A 2023 Chicago Journal paper titled "It's Raining Rockets" outlines several proposed solutions. First, the polluter pays principle. Industry funds cleanup. Second, the precautionary principle. Proof safety before launch. Third, a refundable security deposit modeled on bottle bills. Operators post bonds as a de facto permit, and if damage occurs, the deposit funds remediation without diplomatic battles. This internalizes the hidden cost. The paper argues debris should legally be treated as pollution, like marine or air pollution, rather than left undefined in binding treaties. And beyond space law, alternative frameworks like indigenous rights under UNDRIP may offer stronger pathways for communities currently rendered voiceless. This completes the midterm research arc. Biological evidence proved the cost. Legal analysis identified the structural gap. Fermi problem statement. Now the next phase, the Fermi problem. The 4 cycles build a qualitative case to understand the true scale we need to quantify. I've drafted 4 candidate problems. Option 1, the lethal volume. How many liters of seawater does a single booster splashdown render lethal for marine life? This challenges the dilution fallacy that the ocean is too big to pollute. Option 2, the mangrove carbon deficit. How many hectares of mangrove would offset the 2030 launch cadence emissions? This calculates the biological tax for carbon neutrality. Option 3, the heavy metal sediment layer. How many years until seabed contamination exceeds EPA toxic waste standards? This tests when marine environments become sacrifice zones. Option 4, biorecovery time. If a launch site were abandoned today, how long until the ecosystem recovers? This flips from damage to resilience. The next step is selecting which Fermi problem best communicates the scale of the hidden costs. Conclusion. To synthesize, this inquiry built an evidentiary chain across 4 disciplines. Cycle 1 established global scale, 226 sites, launches up 175%, and mangroves at 5 times density. Cycle 2 identified the mechanism, particle ingestion causing twofold bioaccumulation and synergistic neurotoxicity. Cycle 3 delivered field proof, 106 times mercury, 7 times rubidium in sharks in Alcântara, traced to the 2003 explosion. Cycle 4 diagnosed the legal gap. The 1972 convention excludes environmental damage and defines communities as collateral with no direct standing. The research arc is complete. Spaceports leak toxins, invertebrates ingest them, apex predators magnify them, and the legal framework ignores it all. The key success was proving that hidden costs are not hypothetical. They're documented and quantified. The key challenge, I diagnosed the problem, but I've only partially identified the mechanisms of change. Alternative legal pathways, indigenous rights frameworks, cumulative risk assessment remain unexplored. The open question, how should global satellite benefits be weighed against the concentrated local costs when the legal regime renders those costs invisible? Thank you, and I welcome your questions.